Civil Engineering at the National Institute of Technology, Andhra Pradesh. He obtained his PhD in Civil Engineering from the Indian Institute of Technology, Delhi, with specialization in environmental engineering. He also holds an ME in environmental engineering from Anna University and BE Civil Engineering. Uh, he he has been actively involved in extremely funded research projects supported by the national agencies such as SERB and DST, and he has published extensively reputed peer reviewed journal, total 38 journal he published. At the same time, he published in 17 book chapters, and he participated and presented in the international conferences, 35, totally 35 international conferences. We are truly grateful for his presence today. To your valuable time and guidance mean a lot to us. On behalf of the Department of Civil Engineering and PSV College of Engineering and Technology, I extend a warm and respectful welcome to our honorable chief guest, Dr. Baranidharan sir. May I now request him to kindly accept our invitation and enlighten us with his valuable words, sir. Thank you, sir.
Yeah, thank you, Dr. Lokesh, for the warm welcome. So, I will be presenting my screen.
Sure,
Kindly
sir.
help me whether I could able to do that.
Sure, sir. Sure, sir. I stop my screen, sir. Yes, sir. Your screen is visible, sir.
Yeah, I hope it's
Visible, sir.
in slide mode.
Yes, sir. Visible, sir.
Is it changing?
Yes, sir. Changing, sir.
Okay, fine. So, okay. So, thank you, Dr. Lokesh. So, I can start, right? We'll start. So, participants, very good morning. So, I hope you might have listened to different experts in the last 5 days, and then being at the end of the program, it's a 6-day workshop, FDP, and then this would be the last session, I guess. So, in today's topic, I would be taking you forward, or otherwise, I will be giving you an insight about microplastics in aquatic environments, their behavior, interaction, and their significance. So, how good they are, that is one such thing with respect to aquatic environment. And then, are they really good for the microbes? Second question. And then, how do they interact? Is the third question. So, I hope you might have come across this term called microplastics some time back, or otherwise very recently this term has been very common in most of the news articles or in research items. So that is nothing but the plastics in the microform. So in simple terms, you can just understand that as the macroplastics which have been fragmented into micron size scale, and then their interaction or otherwise their presence in aquatic environment, because water, we wash everything with water, and then sometimes we burn, and then due to the action of environmental factors these pollutants keeps traveling, and then at last joins in aqueous state. So that is the last thing. And then how do they behave, interact, will be the talk forward for today's session. So moving on, so I represent from National Institute of Technology, Andhra Pradesh, and then I'm here for the past 8 years in the Department of Civil Engineering, and then my specialization is in environmental engineering. So plastics assets.
Sorry to interrupt you, sir.
Yeah.
If possible, kindly minimize the Google Meet option, sir. If possible to minimize, sir.
Yeah.
Slide is not visible, sir. Now, okay, sir.
Is that fine?
Now, yes, sir. Now, fine, sir.
Fine. I forgot to do that. Thank you, Doctor. So, plastics is one such medium that has been very recently invented. Since the industrial revolution, we have been using different materials, and then since the last 1 century, otherwise last quarter century, the dependency on this material has increased exponentially. So the material whatsoever that we use, some of the materials have come as a replacement of wood, some for paper, and then for most of the materials, now the medium or the material that has been replaced is nothing but plastics. Plastics, what I mean here is nothing but it comes from crude, so that is nothing but it is a petroleum byproduct. So more and more dependency of the petroleum or hydrocarbon related stuff to our day-to-day activities will yield in more and more plastic materials in our day-to-day life. So until unless we stop extracting crude, it is also one such product. We get from crude, we get petroleum gas, gasoline, naphtha, paraffin, diesel, fuel oil, lubricating oil, bitumen. So bitumen is nothing but the road surface that we have. Lubricating oil, it's been used widely in the industries. Fuel oil for incineration, for boiler plants, diesel for truck movement, etc. Paraffin mostly for the aircraft as a fuel, naphtha for different products, and then one such thing is nothing but the plastics. So plastic is a very big term, but technically speaking, we can classify or otherwise we can call it as polymers. So monomer, polymer, you might have been known what is the difference between monomer and polymer. So here polymers are again different structure be melted, otherwise their form can't be changed. But here, thermoplastics gives us the advantage of changing the shape, how it can be molded in different shapes. That's whatever the material that you think, it can be molded. The plastic or the polymer, it's not to use the right word as plastics. The polymer can be molded, and then given their semi-crystalline structure and amorphous structure, uh, it can be possible. So with respect to semi-crystalline structure, so some of the examples are polyethylene, PET. So this is also one such component that we keep using in our day-to-day life, where we fill the water bottles made of polyethylene terephthalate. Nylon fabric that we use in our day-to-day life, and polystyrene, polycarbonate. So polystyrene is nothing but the foam that comes in the packaging form. Polycarbonate, mostly in the industrial sector, etc., etc. So these polymers come in our day-to-day life in different forms, which they call it as polyethylene terephthalate, high-density polyethylene, polyvinyl chloride, low-density polyethylene, polypropylene, polystyrene, and others. So others mostly in daily walk of life we don't use it, but these symbols are very common in our material that we keep using, be it from the computer parts, be it from the home appliances, be it the kitchenware. Nowadays, we keep looking at whether the plastics that we use doesn't yield to the temperature when we cook or when we store. So different types of plastics are there for microwave oven. Different types of plastics are there for materials that you store in a refrigerator. So the number here corresponds to their recyclability aspect, how easily it can be recycled, and then greater the number, it is very difficult to recycle. So in simple terms, that's the number there it stands for, and then the arrow here signifies the recyclability. And then at last, he is the gentleman who has invented plastics. So I hope now you have understood the wide spectrum of polymers that we keep using, and then how we derive these material in our day-to-day life. And then at last, though we keep using, it forms changes from polyethylene terephthalate to different polymers, or otherwise a simple toy for the children, or a pen, ballpoint pen that we use, the plastic, we keep using it, and then after a designated time, these materials will be discarded or being thrown out as a waste. So here comes the term called microplastics. So once it has been discarded it into the environment, what happens is the question. So let's take the example of polyethylene terephthalate. So we will consider that as a bottle, and then this bottle over a period of time, it stays back in the environment and then it gets fragmented. So normally, most effectively in a developing country like India, these plastic bottles are being taken back into the system, and then it gets remodified and then comes back as a new system. So mostly, very rarely we get these plastic bottles floating, but still, let's assume that there is a plastic bottle made of polyethylene terephthalate. It keeps floating, or otherwise it is there in the environment due to the action of wind, sun, water, the surface can get fragmented, and then it can form into macroplastics and then followed by microplastics. So these microplastics are of size between 1 micron to 5 mm in size. Less than that, less than 5 micron, it can be classified as nanoplastics, and then greater than 5 mm, it can be classified as macroplastics. So here in today's lecture, we will not these that we eat or living creatures, and then it gets at last into the dining table. So with the plastics, which we could not able to visualize through our naked eye, is a problem here. So that's what I said, that so very submicron sized particles of less than 5 mm in diameter. So these particles, the microplastics, can be classified into two different types, primary and secondary. The example I have listed it down here falls under secondary, because a bulk plastic material gets fragmented. So a bulk plastic material, it's nothing but the paper cup that we sip for a cup of a coffee or tea, or otherwise the food that is being served in a polystyrene plate, we keep disposing it off. So those materials, with the action of environment, from the larger to the macro, macro to micro, micro to nano. So this is how it effectively gets fragments. Whereas for these are being designated as tiny, so they don't break, but they are being synthesized in such a way that they are primary in nature. So they can be found in most of the appliances such as sunscreens, the lotions that we keep applying, the car tires, as well as beads that we keep using it for different purposes, the nylons, or otherwise plastics that they keep adding small beads that it is being added into the surface detergents. So moving on, the classification of primary and secondary, as we have understood. So given the chance, all these secondary microplastics, because the improper waste management leads the macroplastics to get converted in a huge scale. Still, with respect to the concern of plastic usage, India is still limited. Somewhere around 11 kilograms per person per year is being consumed. So in such way, the amount of plastics that gets mismanaged is very huge. If you look at it, 140 crore people multiplied by 11 kilograms, that much amount of waste that gets generated. And then just think about the carry bags that gets mismanaged, the plastic bottles, the spoons, the etc. The material that comes as a wrapping, all those material gets mismatched, and then at last it stays back into the environment, gets converted as secondary microplastics, and then it at last enters the food chain. So the main thing is that it possesses a risk to the humans at last, because we are the consumer. At the same time, we are the person who got affected. Just a minute, excuse me. So it has been estimated that water of the fish has been contaminated. Out of 4 fishes that you take it for sampling, at least 1 fish has been contaminated because of these polymers. So though the polymers have been designated, it's for a specific use, but the mismanagement in the environment has led its present into the food chain. So it is for us to quantify how do they get into the stream of water and then at last into the human beings. But given the things, given the chance, whether are we really getting affected is a $1 million question. I'll just let you know why. Because these polymers, yes, please.
Sir, do the chocolate wrappers will come under which kind of category, sir? You told about 7 categories in plastics.
See, very good observation. So those comes under metallized plastic films. Okay, so those are nothing but aluminium wrappers onto the both the sides. It has been metallized with polyethylene layers. So very minute submicron sized things. Yes, they have, because on both the sides you have polyethylene. So there is a chance along with the aluminum. So they fall under that. So polyethylene is being wrapped on both the sides of the aluminum. So we call that as metallized plastic films or metallized films. Not only the chocolate wrappers, the chips covers that comes or whatsoever, be it any of the biscuit packets, all fall under that category. I hope I answered your query.
Thank you, sir.
Yeah. So the million-dollar question is that these polymers in microform are not only being present in water. We have water being the universal solvent. It gets everything into that, and then it retains back. That's the problem. And then apart from that, we have different metal ions to help us, be it cations, anions, or specific concentration is needed. And then all being done. So due to improper management of waste, these waste leaches out as a liquid, and then that liquid contains everything. So be it heavy metals, be it pharmaceutical products, be it PFAS, etc., etc., and then at last it reaches water bodies. And then these water bodies serve as a drinking water source for millions of people across India. So the conventional treatment system, if you are from environmental background, screens followed by primary, secondary, clariflocculators, adsorptions, etc., medium. At last, all these things treat the water, and then at last you get the drinking water. Needs to comply ISA limits for these emerging contaminants. Whichever the contaminants or pollutants that we have, which we don't have limits, we categorize. It can be categorized as emerging contaminants. So these microplastics, when consumed in different forms through food, so that is the solid material that can be consumed, through water, the drinking thing, through the skin, the pores that we have when it gets blocked by the plastic beads of micron size. And these are the pathways in which the humans are exposed. But still, the million-dollar question is what happens to the health of the human being? Recent studies have considered considered these microplastics are a problem to the humans, where it has been found at very, very low concentration in mother's milk, as well as in the blood, as well as in different feces of the kids, etc., etc. So given the question from the audience, so most of the times, in order to open the wrappers, be it the chips packet or something, we keep opening it through mouth. And then that is also a possibility of having that minute submicron sized particles between your teeth. And then there is a possibility of getting it into the food chain. So it has been documented. There are different studies which have found in India as well as across the globe. And then when it comes to microplastics, much focus has been done in the last, say, 8 years, or otherwise in a broader picture of 10 years, where different fishes have been taken into consideration. What is their concentration? Because fish is being the staple food for most of the countries. So there are different concentrations. Concentrations may vary, but the universal fact is that most of the studies have reported their concentration. So it can be 1, it can be 10, or it shall be 15, but the presence of these microplastics are evident now. So to another perspective, so are they available only in the surface water bodies? Studies have looked into the groundwaters. Yes, it is available because of the action of wind. These particles, plastic particles, gets transported because of its low density, gets onto the soil because of the downward gravity motion. These particles gets along between the pores of soils, and at last reaches the groundwater. And then what about rain? So most of the surface water is by the action of rain, precipitation. So yes, it has been proven that in case of a rain event, these airborne plastic particles, which are of submicron size, due to the action of rain, they get precipitated down, and then at last creates a problem to the receiving water body, not only the surface water, as well as the lakes, as well as the plants, as well as everything. So research has been documented for rainwater, surface water, groundwater, oceans, fish, etc., etc. to the farthest point. So not only it has been restricted towards Indian subcontinent or China or US or Europe, to the farthest point. So that is nothing but North Pole also. Studies have been taken and then it has been documented due to the action of current. Current is nothing but the action that happens in the ocean. These particles gets transported and then it has been quantified in the northern pole as well, where very, very less human activity takes place. To a stranger perspective, so it has been also documented that, jokingly, it has been communicated that a plastic that has been thrown onto the shores of Australia due to the action of the wind motion as well as the ocean current, it has been transported to Andaman and then it stays. So that's the effect that these plastic particles can have. So the example that I gave you was macroplastic, not the microplastic. So it is nothing but a water bottle that keeps coming from Australian part to the Indian Ocean. So this problem is not site specific, it's universal, but how fast that we react is all matters. So literature states, I think most of the things I have covered. So with respect to Indian waters, much focus has been done because water is one such medium that everyone consumes. And then water is considered as the most important thing for our life. Doctors first prescribe to have a very good drinking water. So that is where one such thing comes into picture. So most studies in India across most of the rivers, samples have been collected, not only with respect to surface water, the sediments, their fish, as well as their agricultural products have been also subjected to in order to find the concentration. So with our case being located in Andhra Pradesh, when we started the work, very limited studies. I can say that no studies were profoundly found on microplastics. There are two big rivers, namely Krishna and Godavari. So the institute is located between Krishna as well as Godavari. So no much studies were done at the initial time. So it was for our group to first look forward for the local pollution and then look on a macro scale. So that is how it started. And then as I will take you forward. So the knowledge gaps are, so one such thing is that, as I mentioned it, the institute is located between Krishna and Godavari. So we looked into the different water samples to determine how to determine these concentrations of microplastics. And then how do they degrade or how do they react with respect to sunlight? And then third thing is that their absorption mechanism. So given the chance of different pH, ionic strength, as well as temperature, salinity, how do these microplastics behave? And then at last, what happens to these microplastics when biofilm gets formed? So this is one such term, biofilm. In a simple terms, if water has been left over inside a plastic bucket for a week or for more than 10 days, obviously there will be a slime layer that might be formed inside the bucket once you discard the water. So that is nothing but biofilm. So given their small size, these biofilms, because due to the action of microbes, they start growing onto them, and then once these gets consumed by the humans or else by the aquatic species, causes the problem. So this, it's called as bioaccumulation that happens within the species, is one such big problem that needs to be discussed. So when we look back at the time in the early years of 2021, so these we could able to correlate with respect to these knowledge gaps, and then we started our work. So I will take you to these four knowledge gaps. The audience might be from different walks of life. So I'll just give you in a very simple terms how to quantify these microplastics so that the researchers can look around their institutions and then start their work. So the first thing is that what concentration do we have it in river water? So as I communicated prior, so we are located somewhere here. So in the map, we could not able to find it out. So this is assume that this is the place that we are there, and then we are very closely located to Godavari. Godavari is one such river which carries huge volume of sand, fertile sand towards the delta, and then we being there in the delta, it is surrounded with good quantity of water across all the villages. So sampling first started in Godavari River. So being considered as a surface water source for most of the villages in Delta region. So we collected samples, and then it was subjected to the process. So I hope just a minute. Yeah. So kindly stick to this image. So remove it with respect to water bottle. So the samples that was collected were subjected. So these are the sampling points. S1 corresponds to S1 sampling location 2, 3, 4, 5, and then so here the collected samples were first filtered, and then whatsoever that gets retained onto the filter paper. So typically 0.22 micron filter paper was used, and then vacuum filtration was done, and then whatsoever that gets onto the filter paper was subjected or was observed under an optical microscope. So given again one more limitation of this study, or people who wanted to take microplastics as their research, there is no standardized protocol as such. So this is how it needs to be determined, because unless we get the limits, the procedure to determine or quantify or to detect is not clearly available in most of the papers. So whatsoever that it has been documented were followed at that point of time. So still this method is being followed. And then right now additions have come across to add a stain to the filter paper so that the microplastics can be easily visible under the optical microscope. So when it was done, staining was not performed. So in that sense, we picked up the filtered paper, and then it was subjected under the optical microscope. So through the microscope, the size, shape, color, and then the abundance, that means the number of particles in that sample was counted. So that is a manual thing, and then it keeps changing to person. So that was an average thing that we reported. And then to determine the polymer characterization, so what polymer, so assume that we have found a fiber or a transparent film or like a foam kind of thing. So it was subjected to FTAR. So Fourier transform infrared characterization was done to determine the polymer. So what polymer is there in the water? So this was a procedure that was done for this sample. And then this is the picture that represents a person looking under the microscope. And then if you could able to keenly observe a small fiber. So this was to be done to pick up this is somewhat a bigger thing for schematic purpose. We picked it up, and then this will be taken forward for characterization for FTAR. The characterization means advanced. It can be FTAR or Raman. So predominantly, we could able to determine the shape as fiber across all the samples, and then predominantly the color was transparent, followed by blue, pink, white, red, yellow, black, violet, green, etc., etc. So why to determine? Is it most important to know the color? Initially, it was understood across worldwide that color doesn't have any significance onto it, but later on, studies found that the colors resist the degradation of these polymers or plastics when subjected to atmospheric conditions. So that means that yellow will degrade in a different pattern other than white. White will behave in a different degradation pattern compared to pink. Pink behaves differently with respect to blue. Blue behaves different with respect to transparent. So not all the plastic materials will have the same degradation pattern. So kindly understand that. So that's the significance of color. And shape is one such thing. We are very curious. It's very curious to know that what would be the shape of those plastics. So it was found that around between particles of 5 to 24 items per liter were found in the samples that was collected. So microplastics are represented, when it is represented in terms of water, it is represented in terms of items per liter. So that means that number of particles per liter of sample analyzed. Whereas For sand or silt or sediment, it is expressed in terms of kilogram of sample that has been taken and then the number of items. So per cubic meter of sand, etc. So this was published in a journal. So that made a confidence, and then we moved on to the second category of packaged drinking water. So this is one such a terminology which we might have come across. All the people have come across. So packaged drinking water is nothing but the water bottle that is being bought over. You can name any brands. Or otherwise, the simple example where I can give you is that when you move on towards inside a train, people come selling in water bottles. Railneer is one such classical example. So different samples were picked up. Sample here corresponds to 9 different packaged drinking water bottles. So that means that 9 different brands were picked up, and then it was subjected to the same pattern. So filtration. So again, you might ask, sir, why to do filtration? So I'll answer you later. The same characterization, same for characterization for their physical natures, and then same characterization for their polymer structure. So just one point to add for this study. One thing I communicated was the concentration, the shape and color. And then at last it was found that with respect to river, the fishing nets are the main source of these microplastics. So because the fishing nets have been left over onto the sand, and then second most important activity is considered as the drainage of wastewater from the treatment plants, along with the washing activity all along the guards. So that means that the cloths that we wear is getting washed, and then the intensity of washage also matters, and then that also contributes significantly towards into the surface water. So the same thing was carried out, as I said, that extraction, characterization, further advanced characterization. Different samples contributed to different concentration. So in some water bottles, it was around 1 items per liter, close to 1. It is somewhere very, very less, and then somewhere around 3, somewhere around 4, etc., etc. And then you could again look at it. So blue was one such thing, and then different transparent colors were there, and then fibers were predominantly, and then most of the particles fall within the range of 500 to 1000 micron. And then when it looked into the polymer, so now the question comes that how does these packaged drinking water, once it is considered safe, or otherwise it is declared safe from pathogenic materials, but now contains these microplastics. So it can be through the bottle manufacturing. So if you look at the bottle manufacturing, polyethylene terephthalate, it will not be very sturdy. So once the water is consumed, the bottle will not have its strength towards it, and then it can be easily crushable. So that is where the casting plays into picture. So sometimes the resin that is being got from the plastic manufacturer, and then the bottle manufacturing can also add the fibers. Internal finish might not be very smooth. Process, at what pressure the water is being filled, the mechanical stress while handling, transportation, storage, also there is a possibility of getting these microplastics into water, and then at last the chemical degradation, how long it has been exposed to the atmosphere. So so over a period of time, or assume that the water bottles are stacked onto a full day, assume that there is a big gathering that happens in the college, or otherwise a political party organizes a rally, or otherwise it can be a religious function, or anywhere the water bottles are stacked under a tree, or otherwise under a roof or some other shade. So there you will not be able to stop the degradation because of the UV sunlight. So some of the pictorial representations of the samples that we found inside the packaged drinking water are being listed here. So the fibers, pink, or else the fragment, etc., etc. So in water bottles, to your information, the plastic that comes onto the cap is nothing but polypropylene, and then the structure of bottle is nothing made of polyethylene terephthalate. So the major contribution is nothing but whenever it gets opened is also one such source of polypropylene getting into a drinking water. Risk assessment was carried out. So that means that how much risk or otherwise how much number of items that a human individual will be consuming over his lifespan. So from the study, whatsoever the concentration that was found were taken as the least and the maximum. Estimated daily intake, so that is nothing but the concentration multiplied by the ingestion range divided by the body weight, injection rate. So that is nothing but the concentration at what rate it is being injected, and then body mass is nothing but the body weight. So lifetime intake like 60 years. Then it came to be ingestion rate is nothing but 1 liter per day, assuming that a child drinks 1 liter of water per day, whereas an adult, so normally it is recommended as 3 liters per day. On average, if he takes 2 liters per day and his body weight is 70, whereas per se it's 60. So daily intake would be around 1 to 1 microplastics per kilogram of their body mass. Same goes for one, and then at last for a period of 65 years. It will be around coming in lakhs. So somewhere around 17,000 to lakhs. 54,000 would be the microplastics that we will be consuming alone from water. So this was an eye-opening for most of the people. So do we consume these many knowingly or unknowingly? So mostly the answer is unknowingly. It has been consumed, gets back into it stays inside the system because of the biological nature that we have. And then they start accumulating. Because of that, the health impacts may rise. Still, there is no research is still going on. It's very early to comment, but still, it has a significance onto the accumulation. So okay. So here again, from the source. So once we did it with respect to the river. So different, as I communicated earlier, this is a territorial region, and then a very good network of canal system exists here. So one group wanted to start determining the concentration in the canal. So again, samples were picked, different samples were picked, and then they were analyzed. And then at last it was found that it's very high compared to the surface water. So that means that the urban scenario accelerates the presence in the surface water body. So it can be the fragmentation all along the canal side, washing, continuous washing, or otherwise the other materials that can result. So all these things contributed, and then it can be classified as 330 microplastics, whereas in the first time it was around 25 items per liter. And then fiber was dominant. Blue and transparent are frequently noted. So again, next time, whenever you casually move on to a river surface or somewhere, you just think about what is the color of the fishing net that has been used. So it might be blue or a transparent region. So that is where this correlation comes into picture. Yeah. And these particles are larger than 500 microns. So particles could be able to visually easily identify. And then commonly found polymers were polypropylene, polycarbonate, polychloride, nylon, PET. So these are some of the fishing nets that contribute towards that. And then polymer hazard index is very high. And then human exposure here also it corresponds to the previous step. So now you might be able to understand that their presence is inevitable in water bodies. They are there. And then another study, we looked up into a sub-micron size. So we picked up an agricultural watershed. So all those things were mapped from the farthest point till where it gets exit. So it gets moved away. All those points were monitored, and then it was subjected under the same thing. But here, apart from the microplastics alone, so another so that was around heavy metals. Again, what kind of heavy metals are being used, and then what are their concentration, and what is their correlation were also looked into the picture. So this study has been recently published. Last month we had that confirmation. So now it is So in environmental research, so it was clearly found that the microplastics, irrespective of their concentration, has a very good affinity towards the heavy metals. So that we will be again discussing later. So on a summary, with respect to the first knowledge gap that we had, yes, this area, irrespective of the area that we live in, has their concentration either it in the rivers, in the canal, or in the water bottle that we drink, or in an agricultural watershed. Their concentration is inevitable. Their presence is on a day-to-day basis keeps increasing. And the polymers that are identified are polypropylene, polyethylene, polyethylene terephthalate, polyvinyl chloride, nylon, and polystyrene. And among these four, we also could able to correlate higher abundance observed in urbanized and agricultural areas. Urbanized sector always contributes to the population, again, the waste generation, etc. And the estimated intake is nothing but mainly through the drinking water. All of for most of the people that was subjected to. So moving on, any questions till now from the audience? I'll move on to the next one. Okay. So with that as a base, how does this?
Sir, some kind of bioplastics is also available now, sir. So do they have any impact in the study what you have done previously in the Godavari track?
No, actually, see, our focus was not on bioplastics. The concern of bioplastic itself was different. So it gets degraded on their own, whereas microbes consume those plastic materials. Our plastic is mostly related to the hydrocarbons, where they don't decay on their own. So that is different. And then to your answer, no, we didn't. This gets aggravated, or otherwise how fast that they change their nature onto their surface. So smaller their surface, bigger the area, and bigger the area, the problems are more still bigger, because other particles can get onto them, and then they can again start interacting, etc. So again, microplastic formation mechanism. So we wanted to mimic the real world condition. So in that sense, so that is a chamber was made in such a way that UV lamp is being exposed to the particles, and then how do they age with respect to time, so that it can be considered as accelerated aging. So the particles are being accelerated compared to the natural environment. So assume that if 1 day or 30 days, aging can be done in 15 days. So no need to wait for 30 days. So accelerated aging, rather than here in daytime, you have a very good sun exposure between 7 o'clock to 6 o'clock. But whereas in the lab scale, we can able to do it 24 hours. So piston plastic with the help of UV rays, and then how does this free radicals helps in getting their very, very small size was their idea. So interaction, that's what I said that. So how does this biofilm, and then what happens to the surface area? How does the surface gets changed? And then what are the complexation that happens? Something gets on board, otherwise how do their interaction happens with respect to their bonding? As I have already told that polymers are nothing but hydrocarbons. So again, other pollutants. So pore filling is nothing but the other pollutants getting onto them. So whether already we understand that microplastic itself is a pollutant, but assume that if another pollutant gets onto their surface, what happens? So in that case, we looked only with respect to the heavy metals. Heavy metals are again one such medium where you have them in plenty, and then microplastics, how do they react, is still being understood. So in that sense, in simple terms, polyethylene terephthalate. So this is nothing but a packaged drinking water. So nothing to do with the brand. And then this is nothing but the tray that has been taken. The used water bottle was taken, chopped into small pieces, aged, accelerated under aging inside a UV chamber. So for different days, that starting from 30 days to 180 days, and then non-virgin. So non-virgin is nothing but it has not been exposed to different heavy metals of different concentration. So these are the predominant heavy metals that it can be found in any water type: copper, zinc, and lead. Two different microplastics, polypropylene and polyethylene, and then subjected to aging, and then again not with respect to aging. So this we can be called it as virgin or pristine, and then these two aged as well as pristine microplastics will be subjected to characterization, and then at last all the combinations will be taken into an orbital shaker, and then how does this gets adsorbed? So that means that here the adsorbent is nothing but microplastics, and then adsorbate is nothing but the heavy metals. So you have a surface onto which these pollutants gets onto them. So this is how the aging was done. So very tiny microplastics. So 1 mm cross 1 mm. So we made sure that manually how small that it can be made into cut. And then they were sieved. So not the bigger particles were taken into consideration. And then it was done, accelerated aging was done inside the chamber, and then samples. This is how it was placed inside the chamber. So that means that inside a glass petri dish, it was exposed to UVA lamp. Yes?
Yes, sir. So when once there is two different kind of pollutants and it is being absorbed and made into a complex particle, so it will be very tough to treat. And what kind of solution you give it for this kind of problems?
Yes. See, what you have mentioned is nothing but the real-time scenario. In order to arrive at a solution, we need to first understand their individual perspective. So then a complex perspective. Then only we can able to understand how it can be removed. So this is one such first step to understand how do they behave separately, and then how do they behave when all are being present in one go. So we are yet to arrive at the final solution, but we are in the process of arriving at.
Okay, sir. Thank you, sir.
So again, preparation, sample adsorption experiments, and then metal concentration will be quantified with respect to AS, and then the same sample which are subjected to UV aging will follow the same characterization procedure. So there won't be any change in that. And then here, as we are dealing with metal concentration, so AS equipment comes in handy. So here, virgin stands for the unexposed thing. PET stands for polyethylene, polypropylene. UV stands for accelerated aging. 30 stands for the number of days. 60 stands for the number of days. So after 30 days, how the sample looks like, and then how after 60 days, how the sample looks like. So if you could able to see, though the same particles might not reflect in the 60, but if you could able to see that compared to here, the color has started fading. So this was, let's take it this as a medium, or otherwise colorless plastic or polymer. But when it was subjected to 30 days, so it was found to be slightly yellowish in color. And then at last, more the aging, the color started moving towards dark yellowish in color. And then given their surface, if you could able to see slight wrinkles or otherwise fragmentation where we could able to see at 30, but whereas at 60 and for both the cases, fracture started accelerating. So that means that fragments started forming more with respect to 60 days. So that was evident in the other characterizations as well. So that means that with respect to virgin PET, with respect to submicron size, TEM as well, we could able to visualize the small fragments, and then the gaps between, we could able to visually see their surface getting fragmented due to the accelerated aging. So the surface characterization changes, and then that was also evident through FTIR analysis. So functional groups, how does this functional group changes? So over the, without anything, their bonds started giving up. So that means that once these bonds are being shown, so that means that the degradation has happened, and then it leads to increased surface polarity and then chemical reactivity. So again, their surface keeps changing. Because of that, their chemical reactivity with other components also keeps changing. So the chemical reactivity is one such thing that we need to focus on with respect to the heavy metals. How do they react is all what matters. So again, another surface characteristics, the plastics started moving from
Sir,
high. Please.
once again, out of interest, I'm asking. So the this kind of UV exposure, have you used it in laboratory or in the natural sunlight? This process based on that you are telling, sir.
Yeah, that's what I said, that in order to mimic the natural environment, we don't have that much time. So in laboratory, it was performed. So that's what I
Okay.
use the terminology called accelerated aging.
Okay.
So in normal day-to-day life, you will get a sunlight, and then the intensity will be different in morning, noon, and then evening. But in order to have the same intensity at what rate, lab experiments helps us. In natural environment, you have different factors playing into it. So because you will not be able to at last arrive at a final conclusion. Whereas for lab scale, it helps us to uh, mm, remove those variations and then
External
to
factors.
yeah.
Ah, okay, sir. Thank you, sir.
So moving on, the wettability. So that means that the hydrophobicity started changing, and then over the time. So that means that accelerated aging helped the polymer to move from hydrophobicity to hydrophobicity. Once it was reluctant to have water onto its surface, over the period of accelerated aging, their surface started accepting water. So that is what we could able to understand due to accelerated aging. And then again from the XRD, we could able to determine that their crystallinity also changes due to the surface rupture. The wrinkles started forming. Their crystallinity, it can be amorphous or it can be any other thing, semi-crystalline. There's their crystal, the arrangement of the bond started changing. So with respect to different stages. So in that sense, the result was something with respect to as expected. The greater concentration of the copper, as I said that one of the participants also asked, mixture was not performed. So again, copper, how did it behave with respect to polyethylene, and then how did it respond to polypropylene was looked into, and then we could able to see that their adsorption capacity keeps increasing. So microplastics starts behaving as an adsorbent, and then due to their smaller size, their surface change, as well as their hydrophilicity, and then more and more fragments started forming. So more and more surface area. So more and more the metals can get onto their surface. So that is what it was observed, and then given their concentration. So greater the concentration, greater their adsorption capacity with respect to time. So similar experiment was done with respect to zinc. As I said that in order to have an understanding, separate characteristics were done, and then adsorption isotherms as well as kinetics were done with respect to zinc. For zinc, with respect to that we could be able to visualize with respect to the aged plastic particles. So the point is here, one such thing is that could you just wait for a minute? Just a minute. Sorry to interrupt. There was a visitor. So again, in order to mimic the real-time environment, So the accelerated UV aging were varied under different circumstances. How do they behave with respect to different pH, temperature, and salinity? Because again, the water will be of different nature. It might have more ions, etc., all those things. And then how do they behave? Adsorption, how do they change with respect to pH, be it the near neutral or acidic or alkaline? How does it change? The temperature variations also were accounted to mimic the real-time environment. So we could able to see that adsorption was predominantly than acidic compared to alkaline. Adsorption increased or their behavior towards getting the pollutants differed with respect to acidic as well as alkaline in nature, and temperature also played a vital role. Higher the capacity, temperature and viscous, more the temperature, less dense would be the water. Because of that change, the characteristics of the adsorption also changed with respect towards the pollutant. So that the condition that we took here was lead, and then we could able to see that at 15 degrees, the microplastics behave at a higher adsorptive capacity than the other water types. So salinity, so this was also one such thing. As the salinity increases, we had a different pattern. So zero salinity, so that means that you don't have much of the metal ions into it, and then greater the salinity, you have those factors coming into it, and then they started reducing their adsorptive behavior. So again, so given the conditions, near neutral condition, in surface water, their adsorption would be different, whereas for groundwater it would be different, and then the adsorption capacity would be different for a sea water, because all three things have different salinity factor. So these were the results, and then adsorption kinetics helps us to model, and then we could able to have that model oriented towards second order, and then Langmuir fitted majorly towards both the pollutants. And then moreover, for chemisorption was the main mechanism. Not the physical forces were not predominant, though the surface changes happened, and then more and more functional groups were there, but they were bound chemically than the physical forces. So van der Waals force between the microplastics as well as the heavy metals was different. So they were not that predominant compared to the chemisorption. So all these numbers favored Langmuir isotherm as well as the second order adsorption kinetics. So with respect to the characteristics or the knowledge gap that we had, so different, that's what I want to communicate, that in order to not one adsorptive behavior can be correlated with respect to the other. So adsorption behavior would be different for a surface water, whereas it also depends upon the pH, salinity, the rate at which it gets exposed onto the atmosphere, and then what is their role to play, what is the metal concentration, etc. So so through artificial neural network also it helped, and then we could be able to support our variations, or otherwise the input factors that we took, be it the concentration of the metals, be it the aging period. So all it correlated the concentration. So the inputs that were taken as 1 grams of microplastics, the metal concentration was 20 milligram per liter on a higher side. The major thing is that why to take on a higher side. So always, in order to have an understanding, that too when it has been performed for the first time, or to have a better understanding, it is better to go with a higher concentration and volume of sample, the time it was exposed, pH, temperature, UV aging, and then as well as the metal type. So at last, so one such thing is that still now we understood that these microplastics behave different, and then now their surface can have the other pollutants onto their surface. The surface itself changes from hydrophobic to hydrophilic. All this happens, and then including that, if you have microorganisms onto their surface, how do these heavy metals gets on board? So whether these biofilm says no to the heavy metals, or the heavy metals ruptures the biofilm. So is one such thing that we are currently looking into, and then we are yet to get those results, and then it's too early to comment. We are getting some promising results, but due to standardized lack of, again, as I said, that due to lack of standardized protocols, the real world conditions, the diversity of microplastics, different microplastics, colored, again, we haven't taken any of the colored microplastics for our study. All the things that were taken was transparent, because color aging differs, and then weathering simulation, so how fast we can accelerate. So all these things plays a vital role. And then bacteria, again, you need to have a medium to grow. You have a growth phase, so in that sense you need to cultivate them, subject, all those things are being done. So we will come up with a solid results in no matter of time. So these are some of the contributions from this work, which have had an impact onto the local environment as well as to the scientific community. So at this time, I thank all my scholars, and then the supporting agency. Through that, I could able to perform all of those, and then here I am in front of you all to communicate my results effectively. So it is for us to take it forward, how variant that it can be taken, or how much variation still it can be considered to arrive at their concentration, and then a suitable technology can be arrived to remove them effectively from the water. So thank you all for your patience listening. So with this, I will stop. If there are any questions, feel free to drop me a message. My email ID is barani@nitandhra.ac.in. If there are any other questions, feel free to.
Yes, sir. Actually, microplastic, regarding that, many researchers and how we can do and all these things, it was like a question to us. And actually, it feels like a good field to start. But after seeing the mechanism and process, how it happens and other things, it is a very good session from you, sir. Actually, we got many takeaways from that. And one thing I require clarification is, you told that a biofilm can be attached to the microplastic. So with that, can any degradation happen because of that?
See, that's again too early to comment.
Okay.
But studies have said that it all depends upon how the microplastics age factor. There are some microbes, but do we have it in surface water is always a question. And then how do we cultivate them, synthesize them, and then expose at what concentration they can work is all yet to be communicated or yet to be arrived at. So that is one such future scope that needs to be looked into effectively. And then microbially, otherwise biologically, if it can be done, that would be a big breakthrough.
So if we see that we can have either advanced oxidation process, or we can go for any biological treatment for this. So
See,
these
yes,
can we explore, sir?
yes, you can explore advanced oxidation, but
Oh.
predominantly for a country like India, where we are temperate zone, so the tropical conditions favor us for a good. Most of our treatment plants are activated sludge based, so where our
Yes.
temperatures in our surface, land surface is between 25 to 40. So here, predominantly it's microbiological setup. So I would suggest, rather than going for advanced oxidation as a process, it's very fine, good, no
Yes.
comments about that. But
In large scale.
yes, when it comes to large scale of water, with the available setup infrastructure, how to support is always the big question. So if it can be through microbiological or biological ways, it will help us to solve easily, rather than shifting everything from biological to advanced oxidation. See, here we are not dealing about 1 liter of sample or water whatsoever that has been dealt in the lab is very, very minute.
Yes.
Take a city, the wastewater generation would be easily around 10 mld or 20 mld or 80 mld, something like that. Given that huge volume, how to deal is always the question. So
Yes, actually,
There is no comments on advanced taxation. It's a good process. More people are taking, but again, more and more chemicals, high energy demand, and then again the byproducts still that needs to be studied. So all those factors are there for advanced oxidation as well.
yes, sir. Thank you, sir.
Yeah.
Actually, this is an emerging field, as because of that, we have more ifs and nots to go with it.
Yes. Your
I
point is
understand
correct.
this micro.
Ah,
Thank you, sir.
okay.
Any other questions from the participants? I hope that your word is very clear to them, sir. That's why they only one person is asking the questions, others are not asking the questions, sir.
Okay, no worries. See, they can think about that. Later on, they can come back and then they can, when they start working, if they face any problem, they can feel free to drop an email.
Okay, sir. Thank you, sir. Thanking for coming for the research person, sir.
Okay, fine. Again, I thank everyone on your Saturday for taking your time and then listening to me. Second thing is that I take opportunity to thank PSV as well, Dr. Sethuraman and Dr. Lokesh for introducing and then giving me the opportunity to present in front of the audience. So I thank PSV team as well.
Thank you, sir.
Thank you. Okay, so Lokesh, I will sign off.
Okay, sir. Thank you, sir.
Okay, thank you.
Thank you.
Thank you all. Have a nice weekend. Yeah.
Thank you, sir. Participant feedback from posted in the chat box. You will get the certificate after first week of March. You will get the certificate March first week. We need to work out on all the certificates based on your attendance feedback from first day to 60th day. So that's why we need time. March first week you will get the certificate. Thank you. Thank you for joining with the BSc College of Engineering Technology 60 Faculty Development Program. Thank you for everyone to participate this faculty development program. Thank you. You can sign out from this. Thank you.